is responsible for all these collections of the municipal solid waste in each residential areas and even commercial areas as well. So there are two, well, in terms of residential area, there are three different streams. One is refuse, the other one's recyclables. So recyclable can be separated into either mixed or separated. Like we saw, well, it's not really residential, but we saw some separated recyclables at the U of A, right? For instance, U of A is commercial, but or institutional, sorry. But you get the idea, right? And then what's the other big thing is it's the yard waste that we produce as a resident. So these are three different streams. But if you move to commercial in the solid waste collection, it only has two streams, which are refuse, so non-recyclables, and just recyclables. So these are kind of two main differences between the residential and commercial, because in residential we are producing yard waste, and sometimes the recyclable itself we can actually separate it into separated or mixed. So when we talk about the frequency of collection, it totally depends on the waste generation rate. For instance, if you're talking about commercial areas, right? If you're looking into waste collection at stores, hotels, restaurants, malls, anywhere that has a really high waste generation rate, it should be collected daily. Maybe except Sunday, because everybody has to take a day off, right, during the week. But in most commercial areas, they are picking up garbage like almost every day. So it could be like 5 times a day, 6 times a day, depending on the waste generation rate. But it's the takeaway is that it's a lot more often than what they pick up for residential areas. So residential areas, like if you're, I know some of you said you guys are living in a single house, right? If you're living in a single house, most of the time it's like a once a week thing. But if you're living in like maybe high-rise building or mid-rise building, right, where like for example like a townhouse or a condo, right, you might have a lot more waste generation. So it might be up to twice a week, for instance. But in some high-rise buildings, right, if it could be apartment, some of the apartments, sometimes I notice the city actually picks up a lot more often than just twice a week. So it might be closer to what you see in the commercial, the trend of commercial solid waste pickup. So it could be up to 3-4 times a week, depending on the waste generation. But typically, we're just talking about typical cases, right? Typically, the residential area, it's maximum once or twice a week. So in an overcrowded urban areas, yes, it could be like downtown, some sort of like areas like that. Not many, we don't in Edmonton, we don't have too many of that crowded urban areas in the city, except for like downtown. So that if that's the case, right, it's at least twice a week, right? Because I'm in downtown, so that's why I see the garbage truck picking up like garbage from my department for my apartment at least like twice a week. I've seen it like 3-4 times a week these days. Well, it also depends on the weather too, right? But you get the idea. So the main takeaway from this slide is that a lot of the garbage, right, has been picked up or more frequently picked up in the commercial areas because the waste generation rate is much higher. So when we talk about the collection system, now we're actually talking about how the heck we actually collect these garbages, right? So for instance, we have 2 different collection systems. One's halt collection system, denoted as HCS. The other one's the stationary collection systems, which we denote as SCS later in the slide. So halt collection system, there are 2 different modes to operate or to collect. One's conventional, one's exchange container mode. So we'll see how these 2 different operating method or collection method plays a role in HCS. So first of all, okay, I'm gonna move the chat box to the right-hand side now. Can't see my screen. So like I talked about, there are two different mechanical collection systems, right? One's Hall collection system, HCS, the other one's stationary collection system, SCS, right? Hall collection system, right? The truck itself, oops, let me just pull down the chat box straight. The container is actually carried by the truck to and from the disposal site. So it doesn't have the truck itself. So you get the idea from the picture here. So truck itself actually carries the entire garbage bin and then offload it to the disposal area. So truck does not have a container. Yes, sometimes it does have a container because we're going to talk about the exchange container mode. But if it's conventional mode, truck does not have a container itself. So they actually pick up the container, the garbage container from the collection site, and then they'll take that entire container to the disposal site and then bring it back to the collection site. So stationary collection system, on the other hand, it has bigger, the truck itself have a container. So, well, not really a container, but like a storage area. So what it does, it actually picks up these small garbage bins from the residential area. They start loading them onto the truck. So in this case, yes, truck has a container, but the main, so the reason why we have two different collection systems is that HCS, we actually mainly use it for a place with a larger solid waste generation rate. So for instance, HCS is mainly used for commercial areas or maybe institutional areas, but mainly you'll see HCS in the construction site mainly. On the other hand, SCS, it's the capacity itself it looked like it's bigger, but it's actually a lot smaller. So SCS is actually suitable for collecting residential garbage bins or taking care of collecting garbage from residential areas. So you'll see, I'm not sure if anyone's seen HCS like in the picture here. I know this is US Navy, but anyhow, it looks similar to this, but most of the time as a resident, right, we saw more of a SCS collection, right? I don't know if you get seen the collection truck in your area, but yeah, did you guys notice like this the bottom picture? I don't know if you can see my cursor, but SCS is you've seen a lot of SCS truck, right, in your areas or no? Somebody in the chat? No? Yeah, yeah, perfect. Thank you. Yeah, every Friday, there you go, once a week. Perfect. So, oops, I don't know why. Sorry, I'm stuck right now. Okay. Oh, there we go. Oops. Okay, move the chat box. It's a little bit annoying because the chat box, I gotta put it off to the side. So anyways, just continue talking about, oops, no, not here. So just continue talking about, let's say HCS first of all, right? The containers used for the storage waste are hauled to the processing, transfer, and disposal site, and emptied and returned to their original location where they actually collected the bin from or the large container from. So like I said, it's suitable for the areas with a larger or higher solid waste generation rate, like for example, construction site, it could be commercial. So you'll see, unless you're actually working on a construction site or some sort of like commercial, is first some sort of commercial, you probably wouldn't see HCS too much, right? But you'll see a lot, you'll see a lot of SCS. So we're going to talk about two different modes in HCS. For example, I talked about there is conventional mode and exchange container mode, right? So conventional mode, you don't start with, you don't have an empty container, right? So that means the truck itself has to make a round trip between the collection site and the disposal site, right? But on the other hand, if you have an exchange container mode, right, that means the truck actually start with an empty container, right? So they can actually unload that empty container to that collection site and pick up that the bin with the full of garbage, right? And they can pick it up and then they can just offload to the disposal site. So it actually saves it saves like a one-way trip, for instance. So that's why exchange container mode might become like handy for in certain occasions. So the advantage of using HCS, this is over SCS, is that you can actually eliminate any kind of leaks, right, associated with multiple small containers, right? Excuse me. So SCS, because they're collecting small containers at each time, so they might have more leaks, right? If they're mechanically dumping the garbage, right? If some sort of garbage bin has a lot of liquid content in there, that means the SCS might be susceptible of more leakage, right? But SCS, because we're talking about just one large container, and then it will not actually unload, or it will not actually empty that bin until the truck actually hits that disposal site, right? So it actually eliminates a leak, and then it could be more flexible as well than the SCS, right? Because it's not even dumping that garbage into the truck. It's simply just picking it up and then offload it to at the disposal site. So for instance, like if someone like dumps any kind of liquid, right, into the large bin, right, you'll have a less chance of leakage, right? For sure, right? Because it's simply just picking it up and then just offloading it at the disposal site. But the problem with the HCS is that it has a low utilization rate if the containers are not filled, right? So no matter because all the trucks are operated based on their schedule, their own schedule. Most of the time, HCS doesn't have that flexible schedule, right? So it's gonna go to the site every maybe once or twice or daily, right? I talked about it, right? If most of the time HCS is using daily, because HCS is usually used for sites where there's a high solid waste generation rate. For example, like commercial areas or construction site. So it will go to that collection site probably like in almost every day, right? But so regardless if the garbage bin is full or not, right? The HCS will actually collect that garbage or pick up that container and then offload it to at the disposal site, right? So that means if it's like 20% full, 30% full, 50% full, 80% full, it doesn't matter. It's gonna whatever the garbage has been generated on that day or the collection day, they will actually go there and pick it up and empty it. So that's why compared to SCS, HCS doesn't have that of high utilization rate, right? Oops. Don't know why. Okay, there you go. So compared to HCS, so SCS, the definition of SCS is containers used for the storage of waste remain at the point of generation, right? Except they are moved to the curb or at the location to be emptied, right? It's the same thing. They're mainly talking about the residential areas here. So the collection vehicle is actually driven from the pickup location to the pickup location until the truck itself is fully loaded, right? So SCS, if you think about it, because it's collecting the residential waste, right? So it doesn't matter if the bin is full on that day, on the collection day, which is like once a week or twice a week for the residential areas. It doesn't matter, right? Because the truck itself has a large container or the storage area that can actually dump, right? So it's like dumping, right? It's not like completely dumping, right? But it's like dumping into the truck so that the truck can actually serve as many locations as they can until the truck itself is full, right? So that's why I said it's generally used for the collection of residential source separated waste. Well, source separated waste means something else, but it's mainly used for, so that's why it's typically used for the collection of residential waste here. Oops. So the takeaway is that SCS doesn't have a fixed number of containers to be served, right? Or fixed number of locations to be served, right? It can actually go around this, go up and down the row, or go up and down the street and avenue, right? Until they can actually fully load their truck. For SCS, there are two types of collection vehicle. It could be mechanically loaded or manually loaded, right? Manual loaded has been more common back in the days, but mechanical loaded, well, maybe I should probably show the picture here. So mechanical loaded, it's after the green bin program, mechanical loaded has been quite more often used in the city of Edmonton. But we've been using manually loaded back in the days before the green bin, which is pretty much like up to recent years, right? Because green bin program has been established back in 2021, right? So on the left-hand side is the mechanically loaded, right? The truck itself, so you don't really need to get out. You just have to drive to the curb and then kind of use right, the remote to get control and then try to dump that garbage bin into the truck. Well, so it's the loading zone or the loading area, it's on the side for the mechanically loaded. But for manually loaded, you can actually see where the storage area or the opening, the entrance of the storage area on the back of the vehicle, right? So I talked about internal compaction or the compaction ratio back in, I think, module 1 or 2, how compaction ratio is important. Because compaction ratio is very important because it governs how much of the garbage you can fit in that small into that area, right? If it's uncompacted, it's gonna be a little bit hard. You'll be spending a lot more money, a lot more time to pick up, let's say a cubic meter or 100 cubic meter of garbage, right? Because if it's not compacted, your truck will be, full a lot. It gets filled a little faster or a lot faster than if you don't compact it, right? So actually, these vehicles in SCS, they have like a internal compactor with which they can actually compact a lot more. So they start the truck itself has internal compactor. It will compact things inside the truck, and then it's going to allow the trucks to have can load more garbage, right? It can actually serve more locations, can actually collect more garbage here. So any questions so far between the HCS and SCS? Perfect. We'll just move on here. Okay, so back to HCS. That was kind of like the definition or the difference or the advantage and disadvantage between SCS and HCS, right? So starting with the HCS conventional mode. So let's pretend, okay, let me just get rid of the chat box, off the side. Okay, so this is what it looked like. So let's say this is your, can everybody see my cursor mouse here? Yeah, okay. So let's pretend this is like each location and these gray square boxes are the containers, right? This is the location, container, location, container, location, container. So we have 3 different locations here. And then we have a disposal site or transfer station, right? Depending on we're using landfill or different processing facility, right? It could be a transfer station or a direct disposal site, right? So we start with the truck garage, right? Truck leaves the garage, right? Goes to the first location, right? Assuming we have just one container, for instance, in this case, right? It will actually load that container onto the truck, right? and then the truck's gonna go to the disposal site and dump it, right? They're gonna dump whatever the garbage is inside the container itself, right? Unload, right? And then it's gonna return it back to the location, right? So we can actually deposit the empty container, for instance. And then it's gonna drive to the next location, right? Location 2, right? Load the container, and then go to the disposal site, unload, then come back, right? The same thing, the location 3, right? And then so on, right? So for HTS under conventional mode, right? So it needs a round trip. So right, it's gonna have more haul time, definitely, right? So haul loaded and empty containers, right? It needs a round trip between the collection site and the disposal site, right? So pretty simple, right? So, but if you look at, for instance, exchange container mode, right? So truck already has an empty container, right? So that means, right? So truck's gonna load that empty container, right? And then pick up that the container that is full, that was originally on that the collection site, right? And drives to the disposal site, empty it, right? Unload, and then go directly to the second site, right? Second location, right? So they will actually deposit that empty container from the first that was picked up from the first location, and then pick up that container that is full again, and then go back to the disposal site, and then go to the third location, right? Do the same thing, right? So you can see you can actually save a round trip, right, for your first station, and you can actually save a round trip for the next stations as well, right? So it doesn't. Oh, sorry, not next location. So save a time driven between the two locations here, right? As soon as it disposed, or they hit the disposal site, they don't have to drive they don't need time to drive between the first and second site or second and third site, right? They can just directly go to the second site or the third site from the disposal site, right? So that's kind of like the beauty of exchange container mode. So my question to you is, right? I think year to year, from year to year, student actually asked me, "Oh, yes, that was the always the question that I've been getting." Well, I noticed I was getting for the past whatever years I was TAing or teaching this course. My question to you, thanks. Is it Ismail? Sorry if I pronounced your name incorrect, but so everybody has a thought on this. Does that mean the exchange container mode is much better than conventional? What do you guys think? Kind of talk about it. What would be kind of, what could be a possible, drawback of using exchange container mode? Oh, no problem, Nate. What could be a possible drawback of exchange container mode? Any thoughts? See, the advantage is pretty much clear, right? It can save a lot of time, right? It can save. We're going to learn about DVC, like a drive time between the containers or the location. It can save some time driven, right, between the containers or the locations, plus some of the round trips, right, or the one-way trip. But what could be a possible drawback? If the truck actually start with the container, right? Will it add cost? Yes, it's something about the container, right? So exchange container mode, right? If you start with, let's say, for instance, right, there not gonna be a huge, like I'm saying, there may not be a huge difference in time collection time between the exchange container mode and the conventional mode, for instance, right? But because we're trying to maybe save up, let's say, half an hour of time, collection time, and then you're actually, because the exchange container mode needs a container, right? That means we're spending a bit more time, a bit more money on that, trying to get the extra container, right? So we're not talking about like a small garbage bin we have for the residential area. We're talking about a very large, right? A large garbage bin, right? That's on in the construction site, for instance, right? So it will definitely cost money on top if you're using exchange container mode, but is it really worth it, right? Now the engineering came to kind of come into play. Is it worth it to have additional container or to get the additional container to actually save the time, right? For instance, the second reason, right? Second reason where the exchange container mode might not work well is the container size, right? If yes, in city of Edmonton might not be the best example, because in the city, right, city actually regulates all the sizing of the bins, sizing of the containers. But in some other countries or other municipality, right, it might not be the same case, right? The exchange container mode only works if the container size are the same between the locations and between the collection site, right? But if the container size are different, right, then exchange container mode might not work at the best. What happens to the container at the third location, which is full of garbage? Oh yeah, it's gonna take it back. So it's not showing in the diagram here, but it's gonna take this back, right? Go to the disposal site. So people can see my mouse, right? Cursor, right? So it's gonna deposit, it's gonna load this garbage bin, and then it's gonna go to the disposal site, unload it, and then go back to the truck. So this is just showing the last location, right? So it's the same thing. The reason why I didn't, Dr. Dara probably didn't show in the diagram, because regardless if it's conventional mode or exchange container mode, if you finish at the last site, right, go to the disposal site, and then it's going to go back to the truck garage, right, without anything. Good point, Sarah. So do you guys get the idea of sometimes exchange container mode might be more preferable, but it depends on the case, right? It depends on the case. In City of Edmonton, yes, obviously we have the same containers, right? It's a matter of adding or buying additional container to actually save that much of the trip time, right? For instance, right? So any more questions about the HCS? Perfect. We'll just kind of move on. Okay, so now the next would be your SCS collection. Pretty much exactly the same thing that I talked about, but the truck actually leaves the garage, right? Goes to the first location, right? Pick up that truck, pick up the garbage, empty it, unload it back, right? It's gonna go to the second location, right? Third location, and then go to the disposal site at the end if the truck is full, right? So it doesn't need a round trip distance between the disposal site and the collection site, right? Or the container location, right? It just continues to go to the next location or next container that's full of garbage, right? Until the truck itself is completely full, right? And then assuming this last location is the last place where the truck is getting filled up, like completely filled up, then they'll go to the disposal site and completely unload everything and then either return back to the garage, right? Sorry, yeah, either return back to the garage or it's gonna go to another location. Maybe if it's at the end of the day, right? If it's closer to at the end of the day, the truck will just go back to the garage. But if it's still during the day, if there's a lot of time left, right, it's gonna go to the next service area, right? So now you might be wondering, why the heck do we talk about the collection? Because this is where the engineering kind of comes to place, right? I'm gonna move the chat again here. So it's at the end of the day, what we care about for the collection, right? Remember, collection is a huge part of, the whole entire solid waste management, right? It counts for about 40 to 80% of the cost, of the total cost when you're trying to manage that solid waste. So at the end of the day, why the heck we talked about HCS, SCS, which collection system to pick? Because we have to determine the number of trips, we have to determine the number of vehicles required, right? Because it will actually govern, right, the crew size, right? If we have, let's say we need maybe 5 trucks a day, that means we need to hire 5 drivers, maybe 5 more people who's going to be sitting under your shotgun and taking care of all the garbage loading and unloading, right? Especially if you're using the manual garbage trucks. And then it's going to determine how many sites you could serve, right? Depending on the number of trucks, right? It could also govern the length of work, right? How many hours per day, or sorry, how many days a week that we have to go to that collection site to pick up garbage, or it could also govern how many hours we have to spend each day to actually serve these communities and areas, right? And then these two all comes down to play where we talk about economic analysis, right? Now we're talking about money. We're all talking about money. So I think we should probably take a break for 5 minutes here, and then we'll actually talk about actual number, actual and advantage and disadvantage of each. Is that we can have the main benefit in terms of money, right? Economic analysis, right? So in order for us to do that, we have to look at some of the actual math involved in the collection time, right? So the time is money, right? It's essentially, you guys probably know that really famous phrase, the phrase, right? So time is money, right? Essentially. So everything, all the calculations in the collection system, it should be per trip, right? So time per trip, this time per trip is very, very important. That actually governs everything that we talked about in just the previous slide right here, right? So this make sure it's important. Make sure your unit is in per trip, right? So whatever time per trip or something like this, right? So this is a main point because this will actually govern whatever the criteria that we talked about just the last slide, right? So we can actually see how much time we're spending, how much money we're spending at the end, right? So first of all, this time required per trip, right? It depends on 3 different parameters. The first one is the pickup time. So by the way, HCS, I just put the example here, but it could be SCS as well. But anyhow, you get the idea, like abbreviation. HCS is Haul Collection System. SCS is Stationary Collection System. So pickup time, right? It depends on the pickup time, right? We're actually talking about picking up containers, unloading container, these kind of stuff, right? For the pickup time. So at site time, right, is where we actually when the truck actually goes to the disposal site, right, to actually unload everything. It could be waste processing facility, it could be landfill, and so on. So these two, the pickup time or at site time are relatively constant, right? So there isn't any fancy, there won't be any, well, not really any, but there won't be any huge deviation, right? If the, let's say, pickup time for one container is 5 minutes, then it should be relatively constant, right? But your haul times, right, which is denoted as H in here, right? Oops. Before I move on, can everybody, oh, what's wrong with my slide here? Everybody can still see my screen, right? Oh. Oops. Okay. Weird. It's completely frozen. Okay, just give me 1 sec. So these pickup time rate at site time rate, they're relatively constant, right? So it's at the pickup, like at the pickup location or the collection location or the collection site, right? These are the how much of the truck that actually spends on each site, right? Whether it's collection site or at the disposal site. But what's different is the haul time, right? Haul time, this is very important. You should probably double highlight it. But haul time actually depends on the speed and distance, right? It could be your road condition, it could be bad weather, right? Right, all the trucks has to travel between the locations to the disposal site or from the disposal site to your collection site, especially for HCS, right? Is it rush hour? Is it like bad weather? Are there any accidents, right? These are all the haul times that we care. It's all in the haul time, right? It's all considered in the haul time, right? So haul time actually depends on the speed and distance. So at the end of the day, now what we care about is time required per trip, right? If we, for example, if we need like let's say 50 trips, right, and maybe 5 trips per day, then we need about 10 trucks, right? So like if we need like again, if we need like 50 trips, right, and then we have 5 trips per day, or a truck can do 5 trips per day, right? Then we need at the end of the day we need about 10 trucks. So that's gonna add on to your part of your economic analysis. Okay, let me move the chat again. Here's sorry, I won't be able to see the chat right now because I'm just seeing my screen here. So the difference between HCS and SCS in terms of these pickup time and haul time, right? HCS, right? Pickup time depends on the depositing the empty container and picking up the loaded container. While on the other hand, SCS, right? It's loading a number of containers until the collection vehicle is completely loaded, right? It's pretty straightforward. I show you the diagram, so you probably know what I mean by that, right? So your HCS, right? The haul time, right, is a round trip distance or round trip between or from the container, your collection site to the disposal site, right? But on the other hand, SCS is from the last location or the last container where the collection vehicle is completely filled, and then they're going to travel to the disposal site. And then from the disposal site to the first container in the next route or the dispatch station, right? So haul time is quite different between HCS and SCS. And at site time, it's pretty much the same, right? It's going to have just completely unload everything to the waste management facility, right? Or it could be your wait time and unloading time. So these pickup time and site time will not really deviate that much. But your haul time might be a little bit different. It's a different story. But now we're actually introducing another kind of term, right? Off route, right? Yes, and typically it's about 15% of your collection time. It could be some activities, right? It could be some necessary activities, right? Checking in and out in the morning, right? From the first garage, right? You can't really leave the truck without, signing in, signing out, or for instance, like dropping off your truck at the end of the day. And it could be the time spent on like equipment repair, right? If something is wrong, right, with the truck, right? For instance, you have to go back and fix your truck, right? Your tires, engine, and so on, right? But it could also include some unnecessary stuff, right? If you're taking too long for your lunch, then that might kind of add on to your off-route factor. It could be some sort of like a break, unauthorized break, right? You're not supposed to take break, but you're taking a break, right? Or you could be like chit-chatting with your friend over the phone, or maybe when you're picking up, garbage, you could see some neighbors, you can see, hi, hello, right? These kind of stuff, it's part of the off-route factor, right? So it actually accounts for 15% of your collection, right? Just like us, right? We don't always work, right? We're not, even though we're working 8 hours a day, there's a high chance, right, that not everybody will be, focused, right? Will be productive for that during the duration of 8 hours, right? So same as these guys, right? They're not gonna do. There might be some drivers depending on people, right? Drivers or the the pickup guys. They probably don't even they probably don't be like as productive as compared to maybe when they're working yesterday or the day before, right? So it all kind of depends on their off-road factor too, what they're actually doing. So let's start with the HCS, the Hall collection system. We'll look into math, right? In this lecture here. So like we talked about, oops, sorry, this chat box here. So HCS or SCS, what we care about is collection time, right? So for HCS, your collection time depends on the pickup time, right? So collection time I'm talking about is time per trip that we talked about here, this blue box here, right? It's denoted as T, right? HCS, right? Depends on your pickup time per trip for the Hall collection system, right? Again, it's everything is time per trip in this case, right? So S symbolizes the time spent at the site, the disposal site, not the collection site, because collection site we already included in the pickup time here, right? And then it's going to be dependent on your haul time, right? So again, so your collection time depends on your pickup time, site time, and haul time. So you should actually remember these are pretty straightforward, right? So you should probably remember all these. Yes, it's going to be on your equation sheet, but you should probably know. And your collection time is hour per trip, always per trip, right? Always per trip. So remember that. So then these site time and halt time, we'll be looking at each parameter just in the next few slides here. So let's start with the pickup time, because pickup time is what I have in the next slide here. So your pickup time for HCS, it depends on your PC, which is time for pickup the loaded container at the collection site. UC, right, time for unloading the empty container, right? We're actually swapping the container right now. And DVC is a time to drive between the containers locations, right? Again, these are all hour per trip. Everything has to be per trip, right? So these actually add on to your pickup time, right? So time to pick up the container, time to unload the container, right? And then drive between the two different locations or two different containers, depending on how many containers you have per location here, right? So your halt time for HCS, right? Your site time will not really be impacted, right? It's like pretty much fixed, right? But your halt time, like I said, it depends on distance, right? Distance and the speed. Excuse me, sorry. Right, so this equation, H, right? It actually consider that speed and distance, right? So H is total haul time, A is empirical constant, again, hour per trip. B is empirical constant, again, it's hour per mile, right? Or it could be hour per kilometers, because Bx is so A is your speed, Bx is pretty much your distance. So X represent the round trip distance between your collection site and your disposal site. So you should probably take out your highlighter and then double highlight that round trip. A lot of mistake from year to year when I provide maybe one-way trip in the question. A lot of time people actually or student actually forget to multiply by 2 because X is actually the round trip distance between your disposal site and your collection site. So keep that in mind, or your containers, right? So when we actually expand that equation that we saw in slide 30, right? When we actually expand it, it looked like this. So time, collection time for HCS is equal to your PC, the pickup time for your container, for unloading time, unloading your container, right? Drive between the containers, right? Your site time plus your speed and your distance, right? So HCS, right? Pickup time and cycle time are again relatively constant, but your halt time actually depends on speed and distance, right? So that's really important. Your halt time actually depends on speed and distance. So any questions so far? Is it pretty straightforward? I know the math is gonna get a little bit more ugly as we move on to the module, but we good? Okay, well, no response. I assume it's everyone's good. So the last parameter that we have to talk about is number or trips per vehicle per day. This is what we actually want, right? The reason why we did all of these calculations is to actually calculate number of trips per vehicle. Oh, not number or, it's number of trips, right? That's a typo here. Number of trips per vehicle per day, right? So number of trips, not number or trips, is the actual collection time per day divided by the collection time per trip. So it's denoted as ND, and then we have these factors now, right? So the collection time, right, we had in the previous slides, right? We already have the THCS, for instance. But your number of trips, right, will not always just depend on the collection time, will also depend on your off-route factor, right? Or how much hours we're spending per day. So ND is again number of trips per vehicle per day, right? So H represents length of workday per hour, hour per day. So typically, right, we're talking about if you're working full time, we're talking about 8 hours a day, right? So W is the off-route factor. So that's kind of like, efficient, like you're just, assume it is efficiency, right? So if I don't say anything in the question, you can assume it's going to be 15%, right? You can say I can assume W is 0.15. That's totally valid if there's no information given. So T1 is the time required to drive between the dispatch station, right, your garage, to the first container location, and T2 is the other way around. So time driven from the last container or last container location to back to the dispatch station. So dispatch station just means like your truck garage, right? So it actually depends. So we have to consider these two times as well, not just your collection time, right? So we want to get everything, we want to pick up as many or as much garbage as possible within the given time, right? So sometimes T2 and T1 can be neglected if they're not given, but these T1, even if we don't include it, T1 and T2 is already actually considered in W in this equation here, right? So you can actually, once you actually plug and chug, you can actually get the number of trips per vehicle per day. So any questions so far here? Did I whip through this slide pretty quick, or? You guys are extra quiet today. Although probably I can see you guys. Good? Okay. Because we're gonna do the example in the next slide. So ask questions now before we kind of get tripped on in the example. No, we good? Okay, perfect. Well, hopefully. It's okay. I'm gonna get rid of the chat box. Gonna put it in the bottom for a bit. Okay, so here's an example for HCS. It says calculate the number of trips per vehicle per day using the following information here. So the time. So whenever you do example or whenever you tackle a problem, right? Just make a note, right? So if this question was given in the exam, just put like your variable just beside it so that you don't lose track, right? There are a bunch of text here, right? But just we can do it step by step, right? So first of all, the time required to pick up the loaded container is 20 minutes. So what is that 20-minute here? So I'm gonna maybe try to annotate it. What is the 20-minute? T1? Yes, yeah, Madi. So in exact, right? It's PC. Oops, PC. Yeah, there you go. Okay, so I'm just gonna, why is that showing that? Whoops. Okay, there you go. Perfect. So the time required to redeposit or unload the empty container is about 15 minutes. So what is 15 minutes here? UC, perfect. Anyone has that? Site time? No? I gotta give it to you. It's S, right? Disposal site, right? And it says one-way distance to the disposal site is 40 kilometers. So is that 40 kilometer X or X divided by 2? Is X representing one-way distance or the round trip distance? X is one-way distance? Yes, yeah, there you go. Perfect, Sarah. So it's actually X divided by 2, right? So that means your X is gonna be 80 kilometers, right? Because we're talking about the round trip distance, right? So your 80 kilometer will be your X. Whoops, sorry for bad handwriting. I hope you can, it's legible, right? But anyhow, the Hall speed constants A and B are 0.016 hour per trip, 0.012 hour per kilometers, respectively. So these are A and B, we know, right? It's an empirical constant, so we can't do anything about it. So workday hours per day is 8 hours. So this would be your H, right? Perfect. And assume the off-road factor is 15% or 0.15, right? So the average time to drive from the garage to the first container location and from the last container location to the garage each day is 15 and 20 minutes. So these will be your T1 and T2, right? So everybody got it? Yeah. So once you actually lay out everything, perfect. Thanks, Yuan and Eamon. Yes. So once you actually lay out everything in the question sheet itself, your calculations or what to plug in to this equation, it's gonna be a lot easier, right? Or what to plug in Chuck. Oops. Okay, that's not that's not a good thing. It's gonna carry over. Okay, I'm gonna just delete everything. There you go. Trying to delete everything. Okay, but you get the idea, right? I hope I was able to do this lecture in person so I can just physically write on it. Oops. Oops, I can't even. Hold on. I can't even go back now. Oops. Oh, there you go. Oh, there you go. Okay. So once you lay out everything, right, it's going to be easy, straightforward, right? So basically, what we're looking for is, again, right, if you go back to the question, we're looking for number of trips per vehicle per day, right? So which means, okay, I'm just going to use the pen again here, but which means, oops, annotate, oops. We're looking for ND, right? Oops, ND here, right? So if we're looking for ND, right, just go back to your previous slide here. We need, oops, okay. So pretty annoying. So we need collection time, And we're already given these, right? So we're already given these. You don't need to have to play around with your number, but what we need is a collection time, right, per trip. So that means we first have to find the collection time using this expanded formula, right? Pretty straightforward, just plug and chug, right? Just make sure, because we're talking about hour per trip most of the time, right? It wouldn't work with the minute per trip or any other time number. So it must be hour per trip, right? Because your A and B are given as hour per trip. So there's no way, because of these empirical, constants, excuse me, you won't be able to calculate it using minutes. So basically your UCDBC divided by 60, right? Side time divided by 60, just to simply convert your minutes to hours, right? And then your THCS turns out to be 1.98 hours per trip, right? So that means we can use that number to plug it in, and we get the ND, which is your number of trips per vehicle per day, to be 3.1. Everybody can follow that? So my question to you is, this number ND, so we're talking about, number of trips per vehicle, per day. So 3.1 here. Is this something reasonable, you think? What do you guys think? Can you have 3.1 trips per vehicle per day? Or no? So all our calculation turned out to be no, right? There you go. Thank you, Madi, G1, and Amen. No, right? So this based on our calculation, 3.1 is this is the maximum capacity can one vehicle can make, right? This is how number of trips can one vehicle can make per day, right? But 3.1 is not realistic, right? There's no way a vehicle can make 3 trips and then make like a 10% of the trip, right, and come back, right? So this is not realistic, right? It's not possible at all. So that's why you have to, for this case, you have to round it down, right? Round it down. But what if we have, for example, what if you have 3.6 or 3.7, let's say? If our ND kind of came down to 3.6 and 3.7, what do you guys think? Do you have to round it up or round it down? Perfect. Yeah, thanks, Amen. You actually have to round it down, right? There's no way. This is a trip, right? This is one trip that we're making. So there's no way the truck can do 4 trips, right? This is a maximum capacity again. So you always have to round it down. So no matter what, if you get 3.6, 3.7, you have to always have to round it down to 3, to the whole number, right? So yeah, so you always have to round it down, the takeaway. Okay, so we'll probably look at, so any questions so far with the whole rounding? Rounding down, rounding up? No? Okay, so we'll look at another example here. It might be a little bit more clear. So for this one, because we have about 9 minutes left, I'll just probably quickly go through it. Because you guys get the idea now. Oops. Okay, perfect. So again, it's the same thing. Calculate number of trips per vehicle per day for HCS using the following information, right? So again, the pickup time, right? You don't have to read everything here. So, right, you see a word pickup, right? This is PC. You see the word unload, it's probably UC, right? Drive between containers, DBC, right? Disposal or site time is S, right? And the one-way distance, right, is at 40 kilometers again. Or is this the same example? No, it's not actually. Okay, so 40, so your X should be, right, 80, right? And you get the whole speed constants A and B, and work hours, workday hours, 8 hours, so which is H. And we got W this time as 18%, right? It means the drivers or the workers were stacking off more, a lot more, right? And then we have these T1s and T2s, right? Because this represents how much time the truck takes from leaving the dispatch station or the garage to the first location or to pick up the first container. And this T2 is from the last container or last location back to the garage, right? So I have to clear these again, right? Because it's going to carry over. The next slide. Perfect. So we got everything. Again, we look for THCS, collection time per whatever, for collection time per trip, right? So this time, we need about 1.8 hours, slightly less than previous example per trip. And then when we calculate ND, right, it comes out to be 3.25. Now, this is 3.25 trips per vehicle per day. So again, it's not realistic that a truck can do a quarter of a trip. That doesn't make any sense, right? So that means we're left with just three trips per vehicle per day. Whoops. Any questions so far? Okay, so we got about 7 minutes. I think the next example is a little bit different. So I think we should just call it for the day. And then we'll just probably carry on Thursday talking about another type of example.